Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve this together. So in today's challenge I will show you some multiple methods to solve the problem along with the complete intuition. So please stay till the end of the video. So at first it is very important to understand the problem statement. So what is the minimum score triangulation of the polygon you need to find? So if you are given a convex n-sided polygon where each vertex has some integer value, note that these are not any side lengths or anything, these are just normal integer values and each integer belongs to one corner of the triangle. Okay, so one corner of the polygon. So if you are given an integer array values where values I is the value of the ith vertex in the clockwise order. Okay, so polygon triangulation is a process where you divide the polygon into sets of triangles and vertices of each triangle must also be the vertices of the original polygon. Note that no other shapes like triangles are allowed in this division. This process will result in n-2 triangles. You will triangulate the polygon. For each triangle, the weight of that triangle is the product of the values at these vertices, and the total score of the triangulation you need to calculate, and you need to return the minimum possible score that you can achieve with the triangulation of the polygon. So as you can see here, there are multiple such triangulations possible for this value, and you need to find the minimum one. But what is all this, man? What is all this triangulation? If you have not worked with this before, you might need to search the formal definition of triangulation from internet. But yeah, I am here to make things easy for you. So I will show you what a simple triangulation would mean. Let's say you have this polygon. This is also a polygon, right? This is a quadrilateral, but it is also a polygon. So let's say you are given some points. Let's say these are the values which you are given in your array. Okay, a0, a1, a2, a3, and now what you can do is that you can divide this polygon into triangles. So let's say this can be a possible division. So for a side 4 you get 4 minus 2 equals to 2 triangles. Okay, what you could have also done is that divided it into something like this, which would have resulted in a0, a1, a2 and a3, some things like this. Okay, so now what you want to do is that calculate the score of each triangulation. So this is a possible division possible, and this is also a possible division, right? So you want to calculate the score. So what will be the score? This is, let's say, triangle number 1, this is triangle number 2. So triangle number 1 score plus triangle number 2 score. So what is the 1 score? It is nothing but a0, a1, a2 plus triangle 2 score is nothing but a0, a2, a3. Okay, this is your total score. Let it be as 1. Now you can also do by in the same way you can calculate S2 for this triangle to be something like a0, a1, a3 plus a1, a2, a3. Okay, so among the so for this you see there are only two possible ways of division. For a bigger polygon maybe you could have divided into more ways, but among these S1 and S2, whichever is the minimum, you need to return that. So for, let's say, a larger polygon, how would you have solved it? So let us consider some larger polygon, let's say of 6 sides. Okay, so what I can do is that I could have let's say divided it into something like this. Okay, it is very much possible to divide this whole polygon to something like this. I could have also divided, see, each of them is a triangle, right? This is a triangle, this is a triangle, this is a triangle, this is a triangle. Okay, you get 4 triangles from a 6-sided polygon. You could have also divided into something like this. You could have also divided into something like this. You note that these two are actually different. You could have also divided into something like this. Okay, you note that this and this is also different. So yeah, out of all these possible division, out of any possible division that you can actually make from this triangle, okay, so what you could have also done is that you could have also divided it into something like this, this and this. This is also a possible division, right, consisting of 4 triangles. And you need to tell me that which gives the maximum score, which division gives you the maximum score, gives you the max score. Okay. Okay. So I hope the problem statement is at least really clear to you. There should not be any confusion in the problem statement. At least you need to divide your polygon into triangles only, and that will be known as triangulation, and you need to find the score of each triangulation, and you need to tell me that which gives me the smallest possible value, which gives me the minimum possible value. Now there can be actually more ways of triangulating this. I just showed a few examples. Okay, so yeah, that's it. So yeah, how should you approach, how should you at least think of the intuition for solving these kinds of problems? So whenever you get this problem, you first of all you realize that there can be multiple possible ways of this division, right? There can be multiple possible ways, and so you should divide this problem into sub problems. What do I mean by this? Okay, so let's say I consider some vertices from A0 to A5. Okay, A3, A4, A5. Okay. So now what I am trying to do is that I am considering one of my sides as a base. Okay. So let's say this side is a base. You can see that I can form a triangle like this. Let's say this is the triangle which I formed using this A0, A5 base. I am considering this as the base and trying to form some triangles. Okay. So let's say, let me form another triangle. I could have formed this triangle, this triangle. So yeah, again with things I could have formed this triangle. Okay, I could also have simply formed this triangle. So using A0, A5 as base, is there any possible way that I could have formed some more triangles? You see, there are no possible ways, right? There are no possible ways. Okay, now you see, consider this example, this thing. Okay, so what is happening is that whenever you are selecting a base and forming one triangle, the polygon, your whole polygon is getting divided into the triangle, your left sub polygon and right sub polygon. So this, from this you get an idea of sub problems and you can try to solve this. Okay, and so you see, this is your left sub polygon, this is your right sub polygon. Okay, and this is your triangle which is in between. And if you see for this example, for this division, this is your left whole sub polygon, this is your right whole sub polygon, and you have the triangle which is in between. So if I want to tell you that give me a triangulation score for this, like what are the possible triangulation scores, what will you tell me, what will you tell me actually? So you can tell me that my score will be, so let's say my polygon score, let's say I will call it poly score or something like that. Yeah, will be equal to my left score, left polygon score. Okay, left p score, I am telling that, plus these three vertices. So let's say I will just mark them. I am considering this case for now, and it will be A0, A2, A5. This is the score formed by this triangle. You are selecting only one triangle. Okay, so and you have this right polygon score. So you see, you can now apply recursion to solve. So this is the polygon, right? And you got it divided into two more sub polygons. These are the two more sub polygons. Now you can apply recursion to solve this. So you treated this whole thing as a polygon. Now you treat this this as a polygon and this as another polygon. Okay, you treat this as these two as two different polygons and solved it using recursion. Okay, and definitely if you can solve it by recursion, definitely you should look for optimizing methods, like from recursion you should be able to go to memoization or recursive DP. So yeah, how to do that I have already explained you in detail in my DP playlist. You can definitely follow that, and yeah, if even if you don't know, I will try to explain you in detail. Okay, so till now I hope you do get the complete intuition of how to approach and how exactly you should solve this problem. So you get the idea of recursion, and yeah, you get the idea of division if of this polygon into left sub polygon and right sub polygon, and add the score in between. And so what you will do is that, see, this was a possible case, right? This was only a possible case where you consider this thing. Now there is this case also, this one also, this one also, right? These all are there. So what you can do, you can go through a for loop and you just traverse through every of these cases. So in between whichever is the whatever vertices are there in between, only those you need to take care. So considering this as the base, there can be vertices at this. So I will consider this as I and j, and let's say in between this as k will traverse. Okay, so you keep a for loop for k. Okay, you make it traverse from how much, let's say I plus 1 to j minus 1. You can do it like this. If this is I and j, you can make it travel from I plus 1 to j minus 1, and you can simply, I mean, go through it. Okay, you can simply go through it, and for each of this for loop, inside the for loop you calculate for each of this, and you keep a minimum variable at the outside, which you can easily initialize with int max, and you can definitely update your score with this result. Okay, so I hope you can easily update this minimum of mn into this score whichever you calculate. So I hope that will not be difficult to understand. Okay, that you can do easily. So after all this explanation, I will suggest you to pause the video and try to code this on your own, because this should be very simple now and you should be able to write at least the recursive solution. And if you were able to do so from this point, then let me know in the comment section. I will understand that definitely, yeah, some of my explanation was helpful and you were able to solve this now on your own, because that is more important. Okay, I could have told you that watch my video till the end, but yeah, if you pause, it will be beneficial for your own only. Okay, so yeah, you should try it on your own, and then if you couldn't, definitely you can continue watching. So yeah, you have this n equals to value dot size. What you can do, I can call a helper function. So I want to return something like, let's say func. I call a func function, and I will pass these values. I will have, at first I am starting with the base case, which is a0 a5, right? So this is the index number 0 and this is the index number last. Okay, so this index number 0 and this is nothing but n minus 1. Now since this value never changes, as I had already told you, you can use a constant int to better your time complexity by very slight amount all those. Okay, so whatever be the case, you write this, and you got a function, and you can have now a vector of integer, let's say v you can call it, and you have now int I and int j also with you. Okay, so yeah, you do have stuffs, you do have int I and int j. Okay, so what can you say about this now? You can look for base cases, right? So you see, from I to j you are traversing. So j, the index number here, I is 0 and j is 5 for this a0 a5. You do understand that, right? So j is always greater than 5. Now you see, let's say you get something like this. Let's say you get, this is I and this is j, and instead of, let's say there is no polygon, let's say this is a0 and this is a1. What will it mean? J comes immediately after I. If this happens, you cannot form any triangle, right? If this is a0 a1, and this is I and j, you cannot form any k, you cannot place any k in between because they are consecutive. So you cannot form any triangle. So you can tell that if I j minus I is less than equal to 1, then return 0, right? Because you cannot form any triangle with this 1 or even less. So I will tell that if, let's say, j minus I less than equal to 1, return 0, and I will tell that not possible to form any triangle. What you can do next is also very simple, is that you can just tell that if j minus I equals to 2, so it means that you can form exactly one triangle. I hope you do understand what I am trying to say, right? So if you have got something like this, this is I, this is j, and this is, let's say, a0 and this is a2, then you will say that I is 0 here and j is 2 here, so j minus I is equals to 2. So it means that there is one point a1 in between this, which you can form as k, and that is the only case where you can form a triangle. You cannot place any other k. So what you can do is that you can simply return the value for this. This is ai. Okay, this was ai, this I can call it as ai I plus 1, and you can call it as aj. So you can just simply return this ai plus 1 into aj, you can just return it. So what will you return in this case? vi, you can definitely say it something like this, vi plus 1 and v of j. So yeah, you got it. So yeah, possible to form only one triangle, possible to form only one triangle you have in this case. Okay, so yeah, you do have it, and these are all the base cases. Now as I told you, you can have a result outside. We can initialize it, let's say int max, because you need to minimize this result, right? And you can have a for loop for k. Okay, now k will definitely go from I plus 1 to j minus 1. You already know why, right? So they will lie in between I and j, they are that vertices. So you can consider this, and you can consider minimizing this result. Okay, so you will have something like result, and yeah, now comes the thing what you need to minimize. So you see function, so this is a triangle. So I am calling that function as I call this function as I and j when I wanted to traverse from I to j and consider all of those possibilities. When I am consider the polygon from I to j, right? Polygon from I to j. But as I am dividing k, so you see, let's say, let me draw it once again. So let's say this is I, this is j, and this is k somewhere lying in between. So now you have, I wanted to ask for I to j, all of those. Okay, for I to j, the polygon I to j. Now I am dividing into the polygon I to k, polygon k to j plus this triangle. Okay, so let's say the function I to j now gets decomposed into something like function I to k plus the triangle value score and this function k to j. I hope you do get it, right? So what you can write here is simply is that function I to k, I will call the function I to k, I will add some score in between, and then I will also call the function, I will call it in a recursive manner from k to j, and definitely the first value in my recursion is this vector v, which I cannot forget. Yeah, and after all this, you can definitely choose to add the score, which will be nothing but vi, v of I into v of k multiplied by v of j. So yeah, you do have it, and this is the result which you need to minimize every time, and at the end you can simply return your result. That will be it, that will be it for the recursive approach, and I hope this should work. It might give you a TLE, right? Because this is a recursion and there is a recursion tree which will form the exponential time complexity. You know all, I am guessing you all know about this. So this should give you a correct answer, but TLE, yeah, you see 77 out of 99, 94, and you get a time limit exceeded. So how can you solve it? You can convert this into a recursive DP. So I hope you already know how to convert from recursion to recursive DP. What you can do is, instead of calculating the sub problems every time, you can prepare a cache memory which you will call a recursive DP, and what you can do is very simple, I guess. From here you can initialize the whole cache memory by -1. It will denote that this whole memory is empty. So -1 box denotes that the memory is completely empty, and if it is not -1, it will mean that the memory is filled. Okay, so I will just pass these vector functions, and what I will do is that I will check for -1 to say whether it is empty or not. So I will just check that if dp of I and j is not -1, what does it mean? It means that it is not -1 and it has already been calculated. So you don't need to do this whole for loop and things like that. You can just take it from your cache memory and just return it. So do not repeat calculated sub problems is what I am trying to say you. The sub problem which you have already calculated, do not repeat to calculate it again, and at the end you should definitely try to save this result into your cache memory. So you are basically catching this. Okay, or you can tell that you are memoizing this in this step. Okay, so yeah, these are the things which you need to take care. So yeah, I hope now this will work completely fine. And if you try to submit this directly, I hope this will give you an accepted with good runtime also. So yeah, it is giving you only 27% bits, but when I was running it, it was giving me 80%. Okay, so yeah, I don't know what is the issue, but yeah, it varies a lot. You see now it's 58, which is a decent runtime. So with the same code, I also got 80% runtime bits. Okay, so you can try to check for your own, but I hope you do get how to solve this problem clearly. And with you can now also go for the iterative method. Okay, you can follow my DP playlist to understand. I've clearly explained there how you can convert a memoized or recursive DP solution into the iterative one. So you can definitely try it, and you might think that many people directly write the iterative solution. So for this, how you can do it? So from basic, you can simply try to think of something like this. Let's say DP, you can uh, tell that DPIJ, I will consider two states of my DP and as DPIJ, which will denote that polygon starting from uh, starting from I and going all the way till the vertex J. Okay, and definitely you can now think in the same way as I had already explained you, that try to divide it into sub problems, and you will definitely notice that this dpij can be written in the form of dpik and plus some result in between plus dpkj. Okay, so yeah, that is the method which you can try on your own. I will tell you. Okay, so this will be very simple. This is also not a difficult problem. Using iteration also without any recursion, you can easily solve it using the idea which I just told you. So yeah, that's up to you. This also gives you an accepted solution with a decent runtime complexity. So yeah, that's all. That's all for this video, I will say. I will meet you in the next video. Till then, thanks a lot.